today we are going to discuss the next topic is architectural classification schemes. Okay, so the computer architectural classification schemes are Flynn's classification, which is introduced in the year 1966. Then that Flynn's classification is based on the multiplicity of instruction streams and data stream. Instructions mean which are the instructions of our program which are to be executed, and the data stream is the set of data on which the instruction requires to produce some result. Okay, so the Flynn's classification is based on the multiplicity of instruction streams and data streams. Then the next one is Flynn's scheme, introduced in the year 1972. It is based on serial versus parallel processing. Then the third one is Handler's classification. It determines the degree of parallelism and pipelining in various subsystem levels. These all classifications we will discuss in detail. First we discuss the Flynn's classification. Okay, the Flynn's classification is it is the most popular classification of computer architecture, and it was defined by the Michael J. Flynn in the year 1966. Okay, as I told earlier, this scheme is based on the notion of a stream of information. The stream of information includes both instructions and data. The term stream, what does it mean by stream? It denotes a sequence of items, okay, instructions or data that is executed or operated upon by a single processor. Then next, here we have two types of information flow that happens into a processor, that is instructions and data. An instruction stream is a sequence of instructions which are to be executed by the machine. A data stream is the sequence of data including the input and the partial or temporary results called for by the instructions stream to produce some results. Okay, so M.J. Flynn classified the computers on basis of the number of instruction and data streams as follows. They are single instruction stream and single data stream, SISD architecture. Single instruction stream, multiple data stream, SIMD architecture. Multiple instruction stream, single data stream, MISD architecture. Multiple instruction stream, multiple data stream, MIMD architecture. Okay, so in this in all this architecture, it includes some components, that is both instructions and data are fetched from the memory modules. They are saved in both the instruction and data are saved in the memory modules. They are fetched from the memory. Then instructions fetched from the memory are decoded by the control unit, which sends the decoded instruction stream to the processor units for execution. Data stream flow between the processors and the memory bidirectionally. That is, for operation, the operands are fetched from the memory and sent to the processor, and some calculations are performed on the fetched operands, and after those calculations they are sent back to the memory for the result storage. That is why the data stream flow between the processors and the memory is bidirectional. Then multiple memory modules may be used in the shared memory subsystem. Each instruction stream is generated by the independent control unit. Multiple data streams originated from the subsystem of shared memory modules. So what is SISD architecture? As I told, it works on a single instruction and single data. Okay, so it represents the organization containing a single control unit, a single processor and a memory unit. Then instructions are executed sequentially, and the system may or may not have the internal parallel processing capabilities. That is, SISD architecture is purely the sequential execution architecture. It fetch one instruction, execute it, Then after that it fetch another instruction, decode and fetch. Okay, so that it fetch, decode and execute. So the single control unit fetches a single instruction stream from the memory. The control unit then generates the control signals to direct the single processing element to operate on the single data stream. That is, if there happens only one instruction per time, only one operation is carried out on a single time. So single control unit fetches the single instruction stream, then the control unit generates the appropriate control signals for the execution of that fetched instruction, and after fetch then it generates the appropriate signals to direct the control processing elements, which is our processor, to operate on the single data stream. That is, the instruction, fetched instruction works on a single data. So here the instructions are executed sequentially. Okay, then most SISD processes are pipelined. An SISD computer may have more than one functional unit in it. All the functional units are under the supervision of a single control unit. Then examples are older generation mainframes, mini computers, workstations and single processors. Okay. So this is the block diagram. Here we have a single control unit, a single processing unit and the memory unit. Here the IS represents the instruction stream. That is, the instruction stream is fetched from the main memory and it is decoded by the control unit and it is given to the processing unit. Okay. Then DS is the data stream, which is the bidirectional transformation between the processor unit and the main memory. So this is the architecture of an SISD computer. Then next we have an example. As I told you, that support only sequential execution. So first load the instruction load A, then load B. Then operands A and B are loaded and calculation is performed that A and B get added, that is C is equal to A plus B. Then the result is stored. Then on A is equal to B into 2 and store A. So here after execution of one instruction, the next instruction get executed. So the next one is single instruction works on multiple data. Okay, so it contains many processing units under the supervision of a single control unit, because here we have only one instruction but it works on multiple data. Okay, so all the PCs receive the same instruction broadcast from the control unit but operate on different data sets from distinct data streams. So here it represent different works on the same instruction, works on different instruction. So here we have the shared memory subsystem which contains multiple modules, and its examples are processor arrays. For example, the thinking machine CM2, MSPR MP1 and MP2 ILIAC 4. Then vector pipeline systems IBM 9000, Cray XMP, YMP, C90, etc. Then most modern computers, particularly which has the graphics processor units, employ the SIMD architecture. So this is the SIMD block diagram. That is, here we have a single control unit, then different memory units and shared memory module is there, MM1, MM2 and MMN. From this, a single instruction is fetched. From one of the module, a single instruction is fetched and it is given to the control unit, and that single instructions are parallelly distributed onto different processing units. Okay, and they work on different set of data streams, that is DS1, DS2, DS, etc. So this is an example. Here we have load A of 1. Okay, load is the instruction here, but it in the first case in P1 it loads the data A of 1. In second case it loads the data A of 2, and and so on A of n. So the instruction is load, but it works on different set of data. Similarly, it is load B1. Okay, and in the second processor it loads the data B2. Then the third one is the multiplication. First it multiply A1 into B1. In the second case it multiplies A2 into B2, and the data is saved on to different things. So here the instruction is same, but it works on different set of data. Then the third one is multiple instruction stream, single data stream. It is a very rarely used system. Here the multiple instructions operate on a single data stream. Here it is very uncommon architecture. Then the heterogeneous system operate on the same data stream and must agree on the result. Examples are space shuttle, flight control, computer. And this is the architecture. It contains the shared memory unit and the different a set of control units, which single instruction stream work with a single control unit. Here we have multiple instruction and single data stream. Okay, so here it is multiple instruction and single data stream works on a set of CPU control units and processing units. Okay, and we have a shared memory unit. So from this we are fetching different set of instructions from each shared memory units, IS1, IS2, ISN, etc. Okay, different set of instructions are fetched, but they work on the data PU1, same set of data stream. That is, it is given to the processor unit 1, then the output of processor unit 1 is given to output of processor unit 2, and so on. So it works with the same set of data. Different instructions work on same set of data. That is multiple instruction, single data stream. So here we have the example is the first instruction is the load. Okay, but it was load A1, same data is loaded. But see the next instruction. First is C of 1 equal to A1 into 1. But then the second case delta equal to A1 into 4. MAT of n is equal to A1. Different instructions are executed in the second case, but on the same data A1. That's also in the case of next instruction. It is store C1, next is BSI, B of I, then write MAT of n. PSI plus 8. PSI adavade tettu annana A of I plus 8 allengil delta plus 8 എന്നാണ് വരേണ്ടത്. Okay. So it works on the same data. Clear? A1 എന്ന് പറയുന്നതാണ് അവിടെ നമ്മൾ ലോഡ് ചെയ്തിരിക്കുന്ന ഡേറ്റ, but different instructions are executed on the same data. Then the next one is the multiple instruction stream and multiple data stream. It refers to the computer system which is capable of processing several programs at a time. Multiple instruction, multiple data streams parallel architecture are made of multiple processors, multiple memory modules which are connected together using a interconnection network. They are the main two categories that we have: shared memory or message passing. Processors exchange information through their central shared memory in shared memory system and exchange information through their interconnection network in message passing system. That is the most current supercomputers and networked parallel computers, clusters, grid, multiprocessor SMP and multi-core PCs are all example of MIMD architecture. This is the block diagram. Here we have different memory modules, MM1, MM2, MMN, etc. Then different instruction stream processor units and control units. So from each memory we have IS1, IS2, ISN, etc. which work on DS1, DS2, DSN, etc. Okay, so here we have an example. Different types of instruction on different set of data are executed. The first one, load A1. Second is call function D and do 10 equal to I, do 10 times I equal to 1 to n and so on. So different set of data is worked. Okay, so these are the Flynn's classification. So I summarize the Flynn's classification include 4 types of architectures, that is single instruction, single data. Here we have a single control unit, single processor and a single memory. Next is single instruction, multiple data stream. Here we have different memory modules and a single processor, different processor units controlled by a single control unit. That is different same instruction work on multiple data. And the third one is multiple instruction, single data stream. It is the most rarely used architecture. It was multiple data work, same data, single data work on multiple instruction. So it has a set of control units, processor units and shared memory modules. Then the last one is the multiple instruction and multiple data stream. Here we have both different memory modules and processor units and control units are interconnected using interconnection network or a interconnection grid. Okay. Then two types are there: message passing or shared memory. And these are the most commonly, most widely used parallel computer system. So this is all about Flynn's classification. The next classification we will discuss in our next class. Okay.